If you're a plain old computer scientist like I am, and you haven't been working on AI for all these years, and you come to an event sponsored by your lab, and it's called Frontiers in AI, you sort of feel like Cinderella at the ball. And in fact, it seems to me there's a global ball going on, and computer scientists aren't invited to it. So I've been thinking about this and wondering, with all the promise of AI and all the potential for AI-enabled software applications, does software design really matter anymore? Well, I want to tell you today why I think that software design not only matters, but it's absolutely at the core of what we need to do to make successful AI-enabled applications. So I'm going to tell you basically three things. I'm going to tell you some stories, I'm going to give you a diagnosis of some spectacular software failures, and then I'm going to tell you how AI comes into the mix. So first of all, the stories. Now, two of these stories at least are pretty dramatic. But what I hope that won't distract you from is the fact that these stories are actually not unusual at all. Software fails every day. And I'm sure that you will have stories yourself of software failing in exactly these ways. Well, maybe not all exactly these ways, but you'll recognize what's going wrong. OK, so here's the first one. So this happened in the middle of the pandemic. You might have seen this one. For those of us who did see it, probably not for the perpetrators of this particular accident, it provided some comic relief in the middle of the pandemic. What happened was that some poor employee working for Citibank, I believe in India, was intending to repay the interest on a loan, but not the principal. The principal was supposed to be moved into a special so-called wash account. Well, they did slightly the wrong thing. They correctly entered the account number for the wash account, but they didn't enter it also into fields called front and fund. Well, this accidentally transferred $900 million to the wrong person. And this led to a big court case. Citibank, unsuccessfully at first, tried to get its money back. The judge's ruling, actually, is an incredibly entertaining story to read. I liked most the point at which the judge actually excerpts from the email discussions in Citibank that day. Here was one of them. "How was work, honey? It was okay, except I accidentally sent $900 million to people who weren't supposed to get it." But the truth is, it wasn't this poor employee's fault. It was really the software. Here's another example, this one much sadder. Medical devices have a long history of failures. My colleague Harold Thimbleby has just written a fantastic book about the safety problems in medical devices that are grounded in software. And to be honest, these failures are so frequent, you only have to go to the FDA database to find them. So I just went a couple of days ago to the FDA's MORE database to see what the latest failure of an infusion pump was due to software. And sure enough, there was one from May 2023, just a month ago. And here's what happened. What happened was that there was a software upgrade to this infusion pump with the following clever design: that when an alarm was sounded because something had gone wrong with the pump, the alarm would not only make a noise, but the pump itself would be disabled until the nurse came and turned the alarm off. Now you can guess what happened. What happened was the alarm wasn't loud enough, the nurse doesn't hear the alarm, in this case the alarm didn't matter very much, and the pump has just stopped, and catastrophe results. Now in fact, the FDA estimates there have been 500 deaths due to faults in infusion pumps alone in the last 5 years. So this is a huge problem. My third story is a more mundane one and a bit closer to home. Years ago, I saw this very amusing question on Quora. Someone accidentally deleted thousands of my files. How can I quickly undelete them? I love this question because, a computer scientist would never say, how can I quickly undelete them? We'd be happy to get them back at all. But this person is obviously naive and an optimist. Well, this problem might have happened to you. It's happened to a lot of people. And in the middle of the pandemic, it happened to my daughter when she was at home living with me. Here's what happened. She was running out of space on her computer, so she very cleverly listed the largest files on her computer. She then identified the large files that she didn't recognize, thinking quite rightly that she didn't need them, and she deleted them. The problem, it turned out, was that those files were actually in a shared Dropbox. And within minutes, she's getting frantic calls from her colleagues saying, "What have you done to our data set?" Well, at this moment, she calls me in and says, you're a computer scientist. You should be able to help. Well, I'm actually the worst sysadmin on earth. I have to go to my students to do the most basic things on my computer. But I did actually happen to know how to fix this problem. And the reason was that I'd used this particular confusion in Dropbox as the opening example in a book I'd just written. So I'll tell you about that. So here's the diagnosis. What went wrong in all these cases? Well, classically in computer science, we've had this whole story about correctness and bugs and verification. And what we'd say is, well, the problem is there was a bug in the software. But look at these 3 pieces of software, and actually, arguably, there were no bugs. What we need to do instead is take a larger picture, sometimes called a systems picture. And in that picture, there are multiple components, and the failure is not due to any one component, but rather due to the interactions between those components. So in this case, there's the human user, my poor daughter, her computer, and the real world, which comprises the shared files. And the problem isn't that there was a subtle flaw in the computer program, but rather that my daughter was confused about how that program actually worked, and thereby issued the wrong commands. And all 3 of those examples have exactly this same diagnosis. And this is the most common diagnosis for computer failures, from the most mundane to the most catastrophic. So let me just explain to you what was going on in this particular confusion. So here's what happens in Dropbox. If you're Alice and you have a Dropbox, and you put inside it a folder, and you put inside that folder a file, and you now share that with your friend Bob, right? You might think now that because those files and folders are shared, that if, for example, Alice removes the file, then Bob won't see it anymore. And if Alice removes the folder, then maybe Bob won't see the folder anymore. This is entirely plausible and entirely wrong. So in fact, what happens is something much more subtle. Instead, Alice's Dropbox contains that folder by virtue of a kind of pointer that sits inside Alice's Dropbox and points to the folder. The file is contained inside the folder by the same kind of pointer. When Alice shares her folder with Bob, he gets another pointer inside his Dropbox. And notice what's going on here. Both Alice and Bob have their own copies of that pointer. The consequence of this is that if Bob removes Alice's file, that shared pointer that they both have disappears, and now Alice can't access the file. On the other hand, if Bob deletes the folder, then all that happens is that Bob's pointer goes away, and Alice can still reach the folder. Now, a computer scientist would say to you, this is completely logical, isn't it? It completely makes sense. Well, it makes sense in the most perverse way that we computer scientists like to think that things make sense. And to give you, from a designer's perspective, what's so wrong with this is the non-uniformity. That in this case, deleting the file and deleting the folder are in completely different worlds. Deleting the folder simply removed it from Bob's Dropbox, but deleting the file destroyed it for Alice as well. Now, in practice, this didn't really matter so much, and I was able to rescue the day for my daughter with my extensive knowledge of Dropbox, because I knew that Dropbox is a great product, and in addition to having this rather complex shared folder concept, which actually is not due to Dropbox, it goes way back to Multics, which I guess was invented in our lab, so we can take some credit for this disaster. In addition to that, Dropbox also has the trash concept, which allows you to restore files you've accidentally deleted, and an access control concept, which allows you to prevent certain kinds of people from even having the capabilities to delete files. So not so bad. So the key idea here is that the design of software is all about concepts. Now, this idea is an old idea. It goes back to all that great work in the 1980s on user-centered design. I'm sure many of you have read Don Norman's fantastic book, The Psychology of Everyday Things, later renamed The Design of Everyday Things, because it kept getting put in the psychology section of the bookstore. But actually, that was very significant, because really, this work was psychological, right? This whole user-centered design project was about how people think about software. And these concepts were thought of as a byproduct of the design, as a given. The designer's job, at best, was to mitigate the disaster of bad concepts by making sure that the concepts were projected, at least faithfully, to the user in the user interface, so the user would understand those concepts. Now, what I advocate instead is what I call concept-based design, where the concepts are the very essence of the design. And what the designer is able to do is to shape the concepts. And the concepts become not psychological and sort of rather vague things, but they become computational and expressible in a very explicit and succinct way. So here's the shameless plug. I've written a book about this. This might all sound hopelessly abstract to you, but I promise that if you read the book, it's full of exciting, thrilling examples like the Dropbox ones. So finally, the bit you might have been waiting for, the elephant in the room. What about AI? So I see two possibilities, putting it very crudely, for the use of AI in software design. The first is what you might call AI-assisted applications. And in an AI-assisted application, here's what happens. On the left, we have the AI agent, say GPT. In the middle, we have the hapless human user, say me. And on the right, we have Dropbox. And this poor user is trying to figure out how to use this application. In a more sophisticated setting, perhaps the maker of the app has somehow embedded the agent into the app so it can provide advice on the fly and whatever. But for now, this is what everybody's doing, right? We're typing into ChatGPT on the side, asking for help with the use of all these inscrutable apps. So perhaps I'll ask ChatGPT, tell me, is it safe to make space by deleting a shared file? And it will come back and say, yes, but just check that that file isn't in a shared folder. And then, if I can do that check and then discover that, in fact, this file satisfies that particular case, I can go ahead and delete it. Now, an interesting thing to note, GPT doesn't actually know, whoops, sorry, let me go back again. GPT actually doesn't know this particular feature of Dropbox. And I find that pretty fascinating because it knows an awful lot of things. So what does that mean? So in this particular scenario of what I call AI-assisted applications, it's important that the AI actually has enough of an understanding of the app to be able to provide you with good advice. And that means that we're going to need to train these agents with concept knowledge about the applications. Why not just general application knowledge? Because if we train it with concept knowledge, we can modularize that knowledge. And because the same concepts recur again and again between apps, we can use the same concepts for training different apps. Now, a much more dramatic thing is happening where companies are proposing that instead AI will be embedded in applications and will actually sit between you and the application. So in this scenario, you might say to the agent, please make space by removing unused files. It will come back and perhaps say, should I include the files you shared with your friends? And the agent will then actually conduct the action on your behalf. And of course, in this scenario, you'll still need to understand what the agent means when it asks you questions, even if you're operating with it at a higher level. And so in this scenario, we're still going to need concepts, but we're going to need them in order to understand this new AI-enabled software. So in summary, everybody needs concepts. As users, we need the concepts in order to make sense of the apps we use. As designers, we need these concepts in order to design the apps and make them flexible and usable. And from an AI perspective, we're going to need these concepts to train the models that will actually operate these apps. And what I'm inspired by is the thought of building a catalog of succinct descriptions of these concepts that can be used across applications that will fulfill all of these three purposes and give us more powerful, more flexible, and more understandable software for the future. Thank you.